Hello, this is Joseph Schaub, and this is my video demo for Lab4. And here I'm just going to go over my code file. I initialize the stack pointer in the init routine. Have all the breakpoints and function calls set in the main function. Here's my load add to move the operand and result data for add 16 from program memory into data memory. And then here's the regular add 16 function. Where we load the low bytes of both operands and then add them. And then we move the sum of the low bytes into the low byte of the result, and then do the same with the high bytes, except we're going to add with carry, and then we're going to handle that carry so that it correctly updates that third result byte. And we're doing the exact same thing in our load sub16 function. And here's the main logic for sub16. Pretty much identical to add 16, except for we don't have to handle the add with carry. And here is the load mul24 function, loading the operands for mul24, and here is the mul24 function using O loop and I loop. It's gonna go through and it's gonna multiply the low byte and the high byte for each of the operands. And if the add with carry is necessary, this is going to branch to the mul24 carry loop so that it can propagate through the carry into all the necessary remaining bits that the carry might need. This mul24 preserve is to reset the Z pointer depending on how many times carry loop was iterated, so that the Z pointer still maintains where it needs to point at the end of each loop iteration. And then here's the no carry branch, where we decrement the Z pointer twice, and that gives us a good inner and outer loop for multiplying the low and the high bits, and then processing the necessary carry by adding the sum of products together. And here's the load compound function. This is going to clear all the loaded memory done in the previous three functions, because the operands are needed to perform the compound function, which can be seen here, where we call sub16. We load the sub16 result into add 16 operand. Do the same thing here with the add operand, loading the add 16 result into the mul24 operands, and then calling mul24. So the final result of our compound function is going to be at the address 0160. And here's a clear function used in that compound function to clear all of the data memory that we use. And here are all my data memory locations and definitions. Alright, I'll show this working. I'm gonna save, debug, start debug, and break. So let's iterate to the first function call. You can see BA, FC, FF, FF. That is the operands of add 16. Here we got 1 FCB9, the correct result of add 16. Here we have E420 and FCB9, which are the correct operands for sub 16. Continue. And then we have 1899, which is the correct result of sub 16. And then here we have the F values, which are the two operands for mul 24. And then here, that value FFFFFE000001 is the correct result of mul 24. This is loading the compound functions, so notice that all the previous data memory we use gets set to 0. And we continue one more time, and we see our result for the regular compound function right there, FCA8 CEE9.